Hi, it's Mr. Adams from Midwood High School. This is a video on valence electrons. Valence electrons are simply the electrons that are in the outermost energy level of an atom. Okay, so the outermost energy level would be this one right here for the Bohr model. Okay, but we've also been doing a current model of the atom. Sometimes if you're given an electron configuration, it might be a little tricky to see it right away. But there's some simple rules that we can follow to determine the valence electrons in the current model of the atom if we're given a configuration. So what you do first, you find the highest principal energy level. So let's say we have fluorine, right? And we know from experience fluorine is 1s2, 2s2, okay, 2p5. Okay, so fluorine has 9 electrons. Now, in terms of orbital notation, right, we would write it like this over here, right, where 2 electrons would go here, 2 electrons will go here, and the other 5 electrons will go here. We follow Hund's rule, and we get this. Okay, good. Now, what would happen is you would look for the highest principal energy level. Now, 2, okay, is always going to be higher than 1, right? So we're going to ignore 1 right now, and we're going to look at the 2s. Now, also, we must take into consideration that the valence electrons will always be in just S's or S's and P's. They won't be in D's. They won't be in F sublevels. Okay, so you'll be looking for S's and P's. Okay, the majority of the time. All right. So we have 2 electrons right here, and we have 5 right here. Right? They're S and P's. Right? So you just add those up. Okay, so 2 plus 5 gives you 7. So fluorine has 7 valence electrons according to the current model of the atom in terms of sublevel notation. Now, looking at fluorine in Bohr notation is much more simpler because the configuration is just 2-7. So you see right away the outermost energy level contains 7 electrons. So either way, fluorine has 7 valence electrons. Now you can also be asked, right, to sketch a picture of the atom using the Bohr model of the atom. So what you simply do, you can represent your nucleus, right? Okay, here. And you have these circles representing your principal energy levels. This will be principal energy level number 1, number 2, number 3, and so on. Now the big thing here, folks, is that you have to know your electron capacities. You have to know that 2 electrons are in a sublevel. You also have to know, or in an orbital, you have to know how many electrons are held in a particular energy level. And there's a simple rule for that. It's called the 2n squared rule. All right. So once we did that before, so 2n squared for energy level number 1, right? Okay, that tells us that 2 electrons are held there. So if you have, for example, to write map fluorine out, you would put 2 electrons, okay, 1, 2 in the first energy level and no more. Okay, now the second energy level, right, following the 2n squared rule, would go up to 8, right? So we just have 7 here for fluorine, so we just put them in. Okay, we can start here, put 2 right there. Okay, 3, 4, 5, okay, and 6 and 7. Okay, and that's it, you're done. Okay, so that will be representing fluorine. You can also be asked to put your protons or neutrons in, or tell the number of protons or neutrons. You can do that because if the atom is neutral, it would have the same number of protons and electrons, and you just subtract mass number and atomic number to get the number of neutrons. So that's not a problem. We've done that before also when we counted subatomic particles. Okay. Now, in terms of something like chlorine, right, 2H7, using the Bohr model. Once again, they can ask you to sketch the model of the atom. They can ask you how many protons, how many neutrons, how many electrons, and where do they go. Okay, so we see 2H7 gives us 17 electrons, so we know we have 17 protons, right? And those 17 protons would be in the nucleus. Okay, and you can use this number right here, the atomic number, okay, and you take that away from the mass number, and that will give you a number of neutrons. But in terms of the electrons, right, once again, remember, we have to know the capacities. The first energy level number 1, can hold have 2 electrons maximum, so you put it there, and that's what that's telling you right there. The second energy level can hold 8 max, so you put 8 right there. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this outer energy level, we only have 7 left. This valence right here, we have 7 valence electrons. So I'm going to put 1, 2, 3, 4, 5, 6, 7. So that's how you do sketching of the atom with Bohr notation, with Bohr electron configurations. Okay, you know your electron capacities. You just place them in as given. Okay, you can go more than 2 for the first energy level. You cannot go over 8 for the second energy level, and so on. I hope this video was a help. As always, hard work plus sacrifice equals success. Take care.